All right, and welcome to a crash course in probability for the year one stuff. So, okay, let's begin with Venn diagrams. By the way, if you've got the CGP book, just don't bother with this. I'll show you actually exactly what I'm talking about. So here we go. This is chapter 15. Skip this page, man. There's nothing there. Sample space. Don't worry about that. Okay, let's get to the Venn diagrams and two-way tables. I want to tell you about that, how they work. So yeah, let's look at that. Okay, so biggest thing about a Venn diagram, so it's like this. Oh, that's bent as hell. Give me a second, I've got to set up my place. All right, I think we're in action now. Okay, so imagine that's like, this is your Venn diagram. And imagine you've got two things. Ignore that bit, yeah? You've got A and B. So first thing to realize, by the way, A just means something happening. So let's just say, for example, for the sake of actually having some sort of understanding, A equals, I've got a burger in my head, okay? So let's say you order chips. B is you order a burger. All right. So imagine you go to a shop. So this just means basically, imagine you go to a shop. You can either fall into one of three areas: here, 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 or here. Okay, that's the first thing you understand. The outside bit is a place. So let's just talk about one. Yeah. So one is obviously inside A, which is you get chips. But can you see you're not in the B? Just this bit is, you're not actually in B. So this is when you just order chips only. Number two, that's actually in the middle. Can you see? So that's, in a way, you're inside the A circle and you're inside the B circle as well. So that's when you do chips and burger. 3, that's in B, so you're ordering the burger, but it's not inside A. Burger only. And finally 4, never forget 4, a lot of people forget 4. This is all the people that no chips or burger. Okay, does that make sense? That's how a Venn diagram works. And as long as you've got two circles, you've got like these 4 areas. Obviously, I can bring in another one, So imagine do that and I say like that's C. Okay, so C could literally mean you also get like a drink, can of Coke. Okay, now this just that just gives it way more areas basically, but I'll just go through it for the sake of logic. So if let's just first see how many areas there are. I'm not going to bother writing every single one of them. Hopefully you get kind of like the gist. Okay, so for example, let's kind of pick randomly area 4. Okay, so you want to look at the big main circles. Can you see area 4 is in A? So it's in A. 4 is also in C, but it's not inside the B circle. The B circle consists of 2, 3, 5, 6. So it's almost like not B. So that would be so number 4 would be someone who's kind of like, they order chips, they get a Coke, but no burger. Okay, so does that make sense? Number 5, by the way, that's the one and only area which overlaps every single one. It's inside the A circle, it's inside the B circle and C circle. So that's someone who orders chips, burgers and a Coke. Let's look at number 3. Can you see 3 is only inside B? Only inside B. It's not inside A, it's not inside C. So this is your burger only. Okay, so that's how it works. Quick overview of Venn diagrams. All right, so now what we want to do is we want to get really, so this is something that, basically I was going to say this is something that I want you to pay good attention to, make sure you understand, get pen and paper if you need to. what we need to get very comfy on is three things. We need to understand what the you need to understand what the N thing stands for, two, what the O thing stands for, and then when you have like the not, which is usually like a dash like this, okay? So let's first, whoops, bear with me, I'm still kind of like getting used to this. Okay, so imagine that's A and B, and we'll go back to the burger and chips, okay? So A is chips, is whoever orders that, and B is a burger. Okay, so if someone asks you, like, what should I say? Imagine you get, okay, let's just deal with areas first, okay? So we want to first see what is the area of A and B. Well, let's understand what N means, okay? And means, okay? That literally means the area which is in A and in B. It's and in B, okay? So the and it's almost like a really picky one. It's like, no, it's got to be in A and it's got to be in B, okay? Think of it like a spoiled brat. So really the only kind of like area which satisfies, it's this bit, man. Can you see this area? It's inside the A circle and it's inside the B circle. So A and B is that. Now let's look at a few more interesting ones, because as soon as well, okay, that's bear with me, okay. Now let's look at this. So let's look at the and first, actually. Come on, man. Okay, let's look at the not. Sorry, this is the not, yeah. So this would be when someone says, like, you'll see like a dash. That literally means not A. And the best way to figure out what not A is I think it's this way. So think, okay, find all the regions of A and then pick everything else. It's literally as simple as that, okay? Because it's not A. We're talking about not A. So if I kind of just like, if I get the green out, yeah? A consists of this and this. And remember, there's only like, whoops, horrible color. So you got three sections, you got, sorry, four sections, you got that. Can you see? So 1 and 2 are in A. So if we want not A, we want everything else. So we want 3 and we want 4. Okay, so if you were coloring in, you know, so remember that's A and B. So if I now color in red is what I want this and I want all of that. That's the best way, okay, for going for the knots, yeah. And I'll just kind of put some stuff in there. A and B, A or B, and not A. Something like that, okay? Oh, man. Okay. Let's do another one. So not B, say someone says, oh, what's the area of not B? So that's A and that's B. So first pick what B is. So B is that. So literally we want everything that isn't. So it's this area and this area that we don't want. And if we now kind of get rid of, now you can think of it like that. So if I, does that make sense? Yeah. Okay. So B literally, the best way of kind of finding out your ands are kind of think of, well, what is it? And then go, no, I don't want that. Does that make sense? Yeah. Okay. But let's now get to, now let's look at these ands. Okay. So we had a look at what A and B was like. But it's actually, I kind of find that most people don't like it when it's like something like A and not B. That sort of confuses them. Well, let's kind of look at this, okay? So A falls into here. One. No, I've got to think about how am I going to do colors, okay? So let's kind of say A is, oh, fuck. Oops. Okay. A is this area. Now let's think about not B. Now I'm just going to skip a few things. Can you see B is this area? So we want everything but this area. So it's this area and it's also the outside area. So if we kind of do like a quick sketch, similar sketch of this, yeah. A and B kind of literally means, okay, which area is it both in? And can you see it's that one? So it's just literally that one. So that area is A and not B. Okay, does that make sense? Can't speak to me through the screen, but hopefully that makes sense. Okay, now let's do another one. So say you've got not A and not B. So we've got like a little sketch one, and this is like the main one we're gonna do. A, B, A, B. So okay, so for, let's start with blue. So this is A. Okay, so first we're focusing on not A. So here's A, this circle here. So can you see that bit's not A, and also all of the outside is not A. So now let's kind of focus just on not B, and we'll do that in green. Well, here's B, so this bit is not B, and also this bit is not B. So the and, let's not look at that. This one, I keep looking at the wrong one. So the and bit is the bit which has both, which involves both of them, because the and involves both of them. Can you see that's only the outside? So really, not A and not B is the bit on the outside. Hopefully that makes sense. I mean, there's one more thing. Obviously, feel free to look at the book and all of that stuff. Okay, now let's get to A or B. A or B is like the chilled one. Okay, it's like, hey, as long as it's an A or B or both, I don't mind. But as long as it's got something in A or B. So here's how you go about it. So let's kind of look at this is the, so you figure out the stuff in A. So remember, you figure out each one individually. So A involves of that, and now let's go to green. So B involves that bit and that bit. Now if I quickly just draw like a similar sketch here, just to say what area do we want. A or B. So this one, you know how with A and B, we would only want the bit which involves both. Well, A or B just says, hey man, anywhere with this color, any bit which we've chosen, that's fine. Because like, hey, it's or A or B or both. All right, so you just look at, hey, which bits have I colored, and that's it. So feel free to obviously pause this video and stuff. So now let's just kind of look at something else. Not A or B, okay? Okay, so first let's look at what's not A, and we'll do that in red, okay? So this is A. So everything that's outside of A is not A. So we got here, and we got all of there. Does that make sense, yeah? And similarly, let's look at now let's look at B, that's much easier. Well, B is just this circle. So can you see, it's actually, if you kind of do this every time, if we had not A and B, it would just be the double colored one here. So it would just be like there. But we want anywhere where there's color, so we also want the middle bit, and we want the outside. Hopefully that makes sense, okay? So that is the whole thing. You can, I guess I might as well show you this other thing as well. The only other way which they could kind of go, we'll just leave that, that's fine, that's fine, that's fine. I don't want to overcomplicate stuff. Tendency to do that from time to time. Okay, so that's what's the word? Venn diagrams works. But anyway, let's have a look at a question. So let's kind of grab it from this thing. Okay. Brilliant. Bear with me. I know the problem. Okay, so let's actually just take this question for the sake of it. And I'm going to show you how, and we're going to work through actually drawing a Venn diagram from scratch. So here's a question that can go, let's get rid of this stuff as well, don't need it. And let's go back to the pen, okay? So there are 30 students in the thing. 14 of the pupils are girls, and 11 of the pupils have brown hair, okay? So here's what we're going to do. Let's draw a Venn diagram. Give me a second. One sec. Okay, yeah, back. So now, as soon as you're dealing with girls, yeah, the first thing so let me tell you a common mistake, yeah. So there's two things involved. Okay, so one is whether someone is a girl, and one is whether someone has like brown hair. All right, let's just, brown hair. I won't do B. Now, what a lot of people do is they think about boys and girls, and they kind of start writing boy and girl. You don't actually have to, that would be wrong. By just having girl, so can you see everything inside here is girl? That automatically, everything outside here, which is not girl, is another way of saying boy. Because if you think about this as boy and girl, this is what mistake a lot of people, oh, there's girls, so I need to have one for B and one for G. Well, essentially what you're saying here is this area is everyone who's a boy, but not a girl. This area here is someone who's a girl, but not a boy. And this is someone who's a boy and a girl. I mean, that's a hermaphrodite. And you are not going to get those kind of questions in your A-levels. And then this is a weird thing here. This is someone who's not a boy or a girl. Do you see how it doesn't make sense? So the first thing to kind of just notice on this, and this isn't like ultra obvious or nothing, but it's just common mistakes. Obviously, you're kind of like just starting this, you're kind of watching this video, is by just having a circle for girls, you basically got girls and not girls sorted. And when you can either be a boy or girl, that's sorted, okay? So by doing this Venn diagram, we actually want to do a circle for girls. And we also, can you see, 11 of the pupils are girls and 11 of the pupils have brown hair. So we actually want to do a circle for brown hair. So now just kind of quickly, I know this isn't really part of the question in a sense, but let's just kind of, I just want to show you stuff. So we got 4 areas, man. We got 1, 2, 3, 4. Let's have a look. What is 1? Well, that 1 falls into the circle, which is girls, but not brown hairs, okay? Girls, no brown hair. Okay, girls with like red hair or blonde or whatever, okay? They do not have brown hair. Number 2, girls with brown hair. Three is, well, it'd actually be boys with brown hair, but not, you can think of not girls and brown hair, but basically it's boys with brown hair. And 4, it's boys without brown hair. Does that make sense? Well, anyway, let's, okay, that's just for side notes anyway. All right, let's do this question, okay? So here's what the deal. So it goes 30 pupils in the class. So that means, you know, the whole class is made up of all 4 of these sections, right? So can you see these 4 have to add up to 30? That's very important, all right? And that can often be missed when you're starting this. So all 4 of these things. So when I'm going to be putting numbers into here, man, but all of them need to add up to 30. Now here's what I know, okay? So I've been told 14 of the pupils are girls. Now that's actually a problem for me when you're doing these questions, because I can't just put 14 here, because girls is this entire circle. All it means is that this section and this section add up to 14, but I can't put a number in either one yet. So when you're doing Venn diagrams, you've usually got to start with the one which overlaps. Let me show you how, okay? So we know that these two, so we know that 1 plus 2 has to equal 14. And we know that 1 plus 2 plus 3 plus 4, obviously don't actually think of this as maths, okay, if I can circle these. I should have done A, B, C, D, but you get my point, right? So all of the sections have to add up to 30. Sections 1 and 2 have to add up to 14, and it goes 11 of the pupils are brown hair. Again, can you see, so that means sections 2 and 3 have to add up to 11. But again, I can't put it here. I can't put 11 here. I can't put 11 here. Well, can't do that. That's wrong. You know, and it just means that these two add up to 11. So for example, that could be 8 and 3, but I just don't know, man. I mean, it could be the other way around. You know, it could be like 7 and 4. I don't know. That's the problem I have. And finally here, this is the thing which makes it obvious. of the pupils with brown hair, 6 are boys. Okay, so now let's look at this one here. Brown hair is 2 and 3. Now let's think about this. 2, so 2 here, it's obviously they've got brown hair and they're girls. So this is not the section we're talking about. But think about section 3 here. It's not in the girls circle. So that means it's boys with brown hair. So this is the most important one. Because that's telling me that I can put 6 inside here. I know that. Well, now this helps me figure everything out. Because now let's look at the other stuff. I know that these 2 have to add up to 11. Well, if that's 6, that's going to be 5. And remember from earlier, I know that there's 14 pupils who are girls. Well, if I know that 5 of them are here, that means 9 of them are here. And finally, how much do I have altogether here? So 6, I've got 20 here. Can you see? So I need to finally, but I know there's 30 pupils in the class. Bang, 10. Does that make sense? So that's how you fill it in. The secret to Venn diagrams is you've got to start with the one which covers, which overlaps the most. Because if you know the number for that, then, if you know something about this, great. You can just take that middle number away from here. Blah, blah, blah. It's probably best kind of seen if it doesn't make sense right now. Maybe it doesn't make sense. Let's just... Okay, let's go to another question. This one's a bit cooler. Oh yeah. So what I basically just showed you, by the way, I should mention this as well. So obviously in one way, you can do Venn diagrams in 2 ways, okay? And the first one is you're actually putting numbers in here. So that was the last one where you had girls and brown hair. Okay, so we had like 10 here. What was it? 5, 6, 9. We're going to soon learn how to find probabilities. We should actually learn how to find probabilities here anyway. Okay, why not? Okay, so let's go back to that. I didn't finish the question. I just finished the Venn diagram. So it goes, okay, a pupil is selected at random from the class. So can you see, it's going to be selected from the entire class, all 4 things of these, okay? And it goes, find the probability that this pupil is a girl who doesn't have brown hair. All right, well, you've got to first think about which area is girl, but not brown hair, okay? So actually the way you think of that is girl and not brown hair, if you want to think of it like that. And basically, look, it's this area. This is inside the girls, but it's not in the brown hair. So we know that the number of girls with no brown hair is 9. And remember it's chosen from the entire class, so it's 9 out of 30, which can get simplified to 3 out, I think. I didn't actually bother snipping the question out. Yeah, I should have done that. Okay. Let's have a look at that. Okay, let's have a look at part C. Okay. A girl is selected at random from the class again. So can you see they're being selected out of the 30 pupils? So we know it's going to, when we do the probability, we know it's going to be out of 30 because it's all of these. And it goes, a girl is, find the probability that she has brown hair. Oh, my bad. Let's check, look at that. This question matters. A girl is selected at random. So if we look at this again, yeah. So we know it's 9, 5, 6, and 10. Okay. I want to look at 2 very similar questions, okay? And imagine this was D, or let's imagine this was B. This is actually one of the most important things which I don't think too many people understand. Imagine it says a pupil. Okay, let's have a look at this. A pupil is selected at random from the class. Find the probability they, because we don't know it's a girl, we just know it's a pupil, okay? Imagine if it says a pupil is selected at random from the, a pupil is selected at random from the class. So that means it could be anyone here. Are you happy? So this involves 30 people, okay? And it goes, find the probability they have brown hair. Well, the ones which have brown hair are 11. So the answer to this one would be 11 out of 30. Does that make sense? Okay, now this one's more interesting. It goes, a girl is selected at random. So you can they're not talking about these guys. No. These people aren't, sorry, that was brown hair, by the way. Yeah? These people are not in the picture. They are not they're not available for being chosen. So they told you a girl is selected. So we know there's only 14 girls. So this question is going to be out of 14 because a girl is selected. What's the probability she has brown hair? Now your world literally exists of just that. So you shouldn't even be looking at that. That's your new world. Look at this world. Of that, it's saying how many have brown hair? Well, can you see it's just these 5 who do? So the answer is 5 out of 14. Hopefully that makes sense. We'll probably come across a few more questions anyway, fingers crossed. But hopefully, I mean, this is a crash course. Quick fire. Okay, let's look at the next question, which I think is a good one for everyone to look at. Okay, let's kind of start off with the first bit here. This one's interesting. Okay. All right. A survey is carried out to find out what pets people like. The proportion of dogs, which is essentially we're saying the probability of dogs, people who likes that is 0.6. Proportion who likes cats is that. Proportion who like gerbils, one sec, who's calling me? Who cares? Yeah, is this blah 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 blah. Well, actually, no. I should read that. Okay. Proportion who likes dogs. Okay. So we need a circle for dogs. Definitely, we're going to need a circle for dogs. So let's kind of just start drawing a Venn diagram. Circle for dogs. Yeah. Proportion like cats. We're going to have cats as well. And finally, we're also going to have gerbils. So this is a question which involves 3 circles. Okay. So this can be a dog, this can be a cat, and this can be a gerbils. Now, by the way, you know how in the last one we were putting numbers like literally there's 9 dogs there. The other thing you can do is you could actually put probabilities in there. So you know, oh, 0.15 like dogs. And that means all of these sections should add to 1. So all of these sections are either going to add to 1 if you're using probabilities as your numbers inside each one of these. Or if you know, for example, say you're asked 80 people and we're figuring out if they like cats, dogs or whatever, yeah? Then all of it should add up to 80. Does that make sense? Okay, so let's have a look at this. Now, here's the problem. Again, can you see this? There's one area in the middle which overlaps everything. Nothing else overlaps anything. So for example, if we look at that, this one only overlaps dogs and cats, but gerbils are not included. Usually what we're going to need to find this one. That's usually the easiest way. Because think about this, you get told proportion who likes dogs is 0.6. But look at dogs. Dogs is made of sections 1, 2, 3, and 4. Okay? 1, 2, 3, and 4. By the way, 3 is they like dogs, like cats, and likes gerbils. So 3 literally is a section of like they like cats, dogs, and gerbils. But let's look at 4, just for the sake of seeing this. 4 is inside the dog one, so they like dogs. It's also inside the gerbil circle, so they like that, but it's not in the circle, but not cats. Does that make sense? Okay, and that's just for like context. And I might as well actually kind of like delete these. Oh yeah, my point was being, okay, keep flip-flopping every. So it says that it goes, the proportion of people who likes dogs is 0.6. Unfortunately, all I know is that these 4 sections, they add to 0.6, but I can't put 0.6 here. If I do, I'm saying these equal 0, this equals 0, that's equals 0. I can't say that. All I know is that these 4 add to 0.6. Well, that's not very useful for me yet. So let's keep kind of going. Colors. The proportion like cats is 0.5. Again, cats is made up of 4 areas as well. I can't do much with that. Proportion like gerbils is 0.4. 4 areas. Can't do much with that. Proportion who likes dogs and cats. Let's actually look at this one. Proportion who like dogs and cats is 0.4. Again, that's not going to be very useful to me. Because can you see the overlap of dogs and cats? It's 2 areas. It means I know that these two add up to 0.4. But I can't do much with that just yet. The proportion who like cats and gerbils. Again, cats and gerbils. It's these 2 areas. So I can't put, I don't know. All I know is those two add to 0.1. Anyway, let's get to the point. Gerbils and dogs is going to be the same. Finally, the proportion who like all 3 kinds of animal is 0.1. There's this area is the only area which overlaps every single one. So this area literally means they're like dogs, cats, and gerbils. They've specifically told me that's 0.14. So finally in this question, I can actually put a number down for the first time. This is 0.1. Well, this starts leading to a whole, it's like a domino effect. Now I can figure so many things out. So I'm done with that, so I might as well cross that out. Now let's have a look at this. The proportion who like gerbils and dogs. Can you see gerbils and dogs is this area here? That's the bit which overlaps dogs and gerbils. I've been told that's 0.2. Well, I know that's 0.1, so this one has to be 0.1. Okay, that's done. Okay, the proportion like cats and gerbils. Cats and gerbils is this bit here. So this bit and this bit. I know that's 0.1. Well, I know this is interesting. So this one is 0.1. And I know that these two add to 0.1. This is 0. So area can be 0. Nothing wrong with that. That's done. Can you see you're sort of working from the inside outwards? It's like, just work from inside out. I was going to say cancer, spreading. Okay, those who like dogs and cats, that's literally this area and this area. We know it's equals to 0.4. That's 0.1. This has to be 0.3. Right, and then we can kind of get to that. Proportion like gerbils is 0.4. Well, gerbils is this one, this one, this one, and this one. So that one, that one, that one, and that one. This is all supposed to add to 0.4. We already have 0.2, 0.2. So that's 0.2. And similarly, cats. So all of this has to add up to 0.5. So that's 0.1. That's why I need to make that. And finally, dogs is 0.6 because of the loveliest animal in the world. So that's 0.1 to make that. So we got that. Now, are we finished? No. Never forget the outside is an area. This is the area of that miserable kind of guy across the road. He's like, I hate dogs, I hate cats, I hate gerbils. You have to include that. So let's add all of these things up. I get my calculator. 0.1 plus 0.1 plus 0.1 plus 0.3 plus 0.1 plus 0.2. All my probabilities have added up to 0.9, which makes this outside one 0.1. Okay, that's how you do that kind of question. Let's now, so we've done that bit. Let's look at how we find probabilities from it and stuff. Okay, find the probability that the person likes dogs or cats or both. Snippet. Okay, person likes dogs or cats or both. So we need the area which involves dogs and cats. So this one is dogs, this one is dogs, this one is dogs, this one is dogs, this one is and cats actually, and cats. Yeah, but basically this whole area, you see that's the area I want. So if I count all of them up, it's 0.7. Okay, happy with that? And now let's look at the next one. Find the probability that this person likes gerbils but not dogs. And it actually sort of says it there anyway, but I'll show you no way. Great. Okay, probability this person likes gerbils. So the first thing I'll be kind of thinking, if I just draw like another one to be kind of clear with this as well, yeah. So imagine, so it's like first thing, likes gerbils, so it has to be inside this area, but not dogs. So can you see, it's like that was the bit which overlapped with dogs, so I don't want that. I just want everything in here. Well, can you see it was like, and to be honest, it's actually nicer here. So I wish I can't draw like that, okay? Oh, they've got the dog down there. So let's not look at that. Let's look at this one. Let me just black out exactly what I don't want. I don't want this one. This area is no good to me because that's inside the dog one. But I do still want it inside the gerbils. So can you see it's only these two areas? That one's 0 anyway. So the probability here is 0.2. Hopefully that makes sense. Okay. Let's move. Nope. Let's move on. And we can... I'm going to skip two-way tables just because I want to go through something which I think is far more. Should I? Shouldn't I? Okay, you know what? Let me pause. Let me save this.